In this circuit I need to find this voltage V using node voltage method. So what first I will do, I will identify the reference node, which may be this one. So of course the voltage at this point is V, and then maybe this node, let's call the voltage of this node to be V1, and then this one here is already 30 volts because from ground, which is here, there is a 30 volt rise, so this is 30 volts. So this is another node, and let's call this one V2. So we have three nodes here, and the voltage, this becomes a node because we need to find that voltage. So what first I will do, I will write the KCL for maybe this node V1. So I can see this one here is an entering current 4.5. So what I will do, I will write the leaving currents as positive and entering currents as negative, or maybe the entering currents on the right hand side. Let's do that. So leaving current, this one, let's call it leaving here. So V1 over 1, then V1, the current that goes in this direction will be V1 minus V over 6, and the entering current which goes on the other hand side, so on the right hand side, which is 4.5. So I have like this. So maybe I multiply both side by 6, so I get 6V1 plus V1 minus V is equal to 27 there. So that becomes 7V1 minus V is equal to 27, or what I can write is, what I should try to do here is, since I am interested to find V, when I will write the KCL equations for all the nodes, I will end up getting V1, three unknowns, V1, V and V2, but I want to know what is V, so I will express all the equations in terms of V. So instead of V, I will substitute, I will write it like that. Instead of writing like that, I will substitute V1. So this is my V1 in terms of V. So just like that. Then I will write KCL equation for this node V2. So now V2 minus V is this current in this direction. So that will be V2 minus V over, which is 2. The resistance is 2 here, this one. And then the outward current in this direction through the 12 ohms resistance will be V2 over 12, so plus V2 over 12, and finally the current in this direction will be V2 minus 30 over 4, so V2 minus 30 over 4, so that's equals to 0. So when I multiply both sides by 12, I will get 6V2 minus 6V plus V2, and then finally this one will be 3V2 minus 90 plus 3V2 minus 90 and equals to 0. So this is becoming 10V2 minus 6V is equal to 90. So that's there, and this one also I will write in V2 in terms of V. So it will be 10V2 is equal to 6V plus 90. So V2 will become 6V plus 90 over 10. So this is my one finding, V1 in terms of V, and this is the other one, which is V2 in terms of V. Now finally I will write KCL for this node. So there's just two branches. Basically it wouldn't be a node, but I've just made it a node to solve the problem, because this is the voltage I want. So this is the current that goes in this direction, and so maybe one current entering, one current leaving. So V1 minus V over 6 is the same current, that is V minus V1 minus V over 6 equals to V minus V2 over 2. So I will just write that V1 minus V1 minus V over 6 that is the entering current, let's say, and the leaving current. So I have now written the entering current and the left hand side, but doesn't matter basically. So this one V minus V2 over 2 will be the leaving current. So V minus V2 over 2 is their leaving current there. So I have this equation, so it becomes, now I multiply both sides by 6, so it becomes V1 minus V is equal to 3V minus 3V2. So that's V1 plus 3V2 is equal to 4V, like that. That's what I get here. So let's call this equation 3, and then in this equation I will write, I will substitute V1 and V2 by V. So V1 and V2 is, I have found previously, so V1 is V plus 27 over 7, V plus 27 over 7 plus 3 here, and V2 is 6V plus 90 over 10, 6V plus 90 over 10, and this is 4V here. So I need to multiply both sides by 10 now. So there's a bracket here basically. So if I multiply both sides by, 70 I need to multiply both sides by, because 7 in the denominator here and 10 here. So multiply by 70, so that becomes 10V plus 270, and then this one becomes, so here it will be 7 times 3 times 6, so that becomes 126V plus 1890, something like that, and on the right hand side I have to multiply this one by 70, so that's 280V. So once I do all this, and once I take the V's on one side and the non-V's on the constants on the other side, what I get is 144 V is equal to 2160. So V becomes 15 volts. So that's the result. This is what I get in the end. So just double check the calculations here, but that's pretty much the procedure. So I have used a node voltage method to find this unknown voltage there.